Hi guys, so today we're gonna finish up the last section last section for your homework is 2.4. And 2.4 is all about average rate of change. And it's gonna be a short one, but there's a lot of details with it. So let's take a graph. Let's make his way. And then the question is, if I were to give you a graph, and then I were to ask, hey, what is the average rate of change? What is the slope? Or any of that stuff. The two words are synonymous. But the problem is, this is not linear. It's not a straight line. It's very hard to figure out what the slope is because it depends on, so average rate of change depends on 2 points. You need 2 points to figure out the average rate of change. Likewise with slope, you needed 2 points. y2 minus y1 over x2 minus x1. So it does matter in our problem over here where our slope is low or what point we're going to be using. Because if I were to take the slope from here all the way to here, that is significantly different. The rise over the run is significantly different than over here to here. So how are we actually going to tackle that? Well, average rate of change, let's suppose I were to draw this, and this is my x, and this is my f of x. Well, I'll call this the y-axis. That way I can call the function f of x so there's no confusion. If I want to find the average rate of change between 2 points, let's call this point the input A. Let's call this point the input B. So the average rate of change from A to B is simply going to be your rise over your run. However, because it's not linear, we think of this topic as, or we think of these 2 points and we construct a secant line. This is a bad one. Let me erase that. If we can construct a secant line between these 2 points, yeah, mine is not the best. I'm gonna give it one more shot. Yeah, it's pretty close now. If I can draw a secant line, well, now I know how to work with the slope. I can't work with the slope if it has curvature or anything like that, but I know how to find the slope between 2 points in a straight line. This is called the secant line. So we're going to draw a secant line connecting the 2 points. Oops, secanting. It's just secant line. Average rate of change from A to B is the slope of the secant line that passes through A to B. A to B. It passes through A to B. So we can write it as a function. You know that slope is simply, so I'm going to say average rate of change is equal to slope of secant, which is the same thing as being equal to whatever m is, rise over run, equals y2 minus y1 over x2 minus x1. Now, because we're working with functions, they're not going to be as simple as that. We need to somehow refer to our function points. And we're not going to be using x1, x2 anymore, or y2 or y1 anymore. Instead, we're going to relate it to our function. So instead of saying y2, y1, we're going to say let's work with the denominator first. We're going to work with our input B minus our input A. And this is all over going to be the outputs of those inputs. So it's going to be the function of b minus function of a. This is simply inputs, and this is simply outputs. This is the language we'll be using from now on. Instead of y2 minus y1, we're going to use f of b minus f of a if b and a are our first 2 points. Now, because we read from left to right, we do b minus a instead of a minus b, because we want to figure out the distance. And generally speaking, on the right side is more positive. So this is the main thing we need. Average rate of change is going to be this. But you can think of it as a slope of the secant line. You can think of it as rise or run, all of that good stuff. And I encourage you guys to think about this. So the idea here is we're going to be doing b minus a. We're going to subtract the larger value with the smaller one. But then now we can go from this point to this point. This is f of b, and this is f of a. So we're going to subtract that value. And a lot of books you'll see will try to show you this little piece right here. Because the idea is that we are finding the ratio between our slope, our rise and our run. So we're seeing the comparison. Hey, how much, or if I move my inputs all the way to B, how much does my output go? Where is it located at? And that is the idea. So this is not too bad of a problem, because when we're doing any sort of kind of work, we just need to figure out what the average rate of change between two input values are. Well, let's take a generic function. Let's take, let f of x equals x minus 3. What if I were to ask you, find average rate of change from, let's say, x equals 1 and x equals 3. Well, to do this problem, we know we need f of b, or f of b minus f of a all over f, or our output subtracting minus our inputs, b minus a. So we already have our values. Our b value can be x equals 3, and our a value is 1. Whereas our output values are going to be f of 3 minus f of 1. So we get an idea of how to work with things easily. And all we're doing now is just figuring out what these values are. If we can figure out what these two values are, we can figure out that ratio, or the slope of the secant line slash average rate of change of our function. So if we were to calculate that out, our function's over here. Let's figure out what f of 3 is. F of 3. Well, that's going to be equal to, if I input my 3 minus 3 squared, which is going to give me 0 squared, which is 0. Well, great. Now let's do f of 1. If I plug in f of 1, I get 1 minus 3 squared. 1 minus 3, that's going to be negative 2 squared, which is exactly positive 4. A negative times a negative is a positive. So this ratio becomes 0 minus 4 all over 3 minus 1, which is exactly negative 4 over 3 minus 1, which is going to be 2. And if you simplify that, you get negative 2 is your average rate of change. So average rate of change from 3 to 1, x equals 1 to x equals 3 is negative 2. And what does this mean? That means our function, however it behaves, is going to be decreasing. I don't know what my function looks like. Well, I kind of do, but let's just assume I didn't know what my function looked like. The idea is that it's going to have some sort of negative rate of change. So it might have something like that. I don't know. Between x1, let's say, is x1, and x3 right here. So right here, we'll have a negative slope. It's going to go downwards. It's going to be decreasing. That's what it means to have a negative slope. So that's how we deal with average rate of change. That's all there is to it. Now the part that I care about is trying to understand it. So again, if it has a negative average rate of change, that's a negative slope, which means your graph might be, I don't know, might be decreasing. If you had a positive average rate of change, that means your function is increasing. I don't know what my function looks like. I'm just giving arbitrary ones, but that means from here to here, it's probably increasing in a positive slope. But the whole point that I encourage you guys to think about now is average rate of change. We can see it as slope. It's the idea between the change in y. Some people say the change in y over change in x. And why do we say change? Well, we're just going to see, hey, what is the difference between our x value? That's just the change in x. How much am I changing the a value to get to b? And in calculus, you might see this as delta y over delta x, which is the exact same thing as change in y, change in x, or like I said, you can see this as y2 minus y1, x2 minus x1, which is the same thing as saying f of some value b minus f of some value a with those corresponding inputs. So it's not really a hard thing to figure out. You just got to figure out how to calculate f of b and f of a with your function. If you're able to do that, this problem shouldn't be too bad. So the last thing I want to talk about before we end it off is pretty much what is instantaneous rate of change. And I'm not going to go into too much detail, but I want you guys to understand this because we have work with something. It's the function, let's say I have g of a plus h minus g of a all over h. I'm going to tell you that the problem about our average rate of change, we're just averaging between 2 points. We are not able to find the specific slope or the rate of change. Another word for rate of change is speed. We're not able to find the speed of an object at that particular moment. We need 2 points. If I were to ask you what is the speed of the vehicle, where is it, how fast is it going? The problem is average rate of change requires 2 points. I need to know from point A to point B. However, when you use a speedometer, you're able to track the speed at a singular point. How is it able to do that without using a second point? Well, that's when the instantaneous rate of change is. So if I scroll down, in particular, this h is super small. So the idea is that we're going to move our input a to our input a plus h by a very small amount. So you might see this is more, even though a lot of teachers work with this, they never really show you what this actually is. So in reality, this is the exact same thing as your average rate of change, f of b minus f of a, your outputs subtracted over your input subtracted. But you don't see your inputs at all. So let me go write that down for you. G of a plus h minus g of a. Well, if I subtract my inputs, a plus h minus a, what do we notice? We get g of a plus h minus g of a all over a plus h minus a. Well, you notice that this cancels out. And that's exactly where we get g of a plus h minus g of a over h. So it is exactly your average rate of change. It is exactly your average rate of change. The idea with this is that if I were to take a graph, boom, and then let's suppose I had some crazy function, and then this is a. The idea is that, hey, if I were to poke this a, if I were to slightly move it, let's move it to a plus h. This is the distance between a plus h is h. If I slightly move it by some small number, and the best part is because I made this a variable, I can make it as small as I want to. Well, because I did this, I can figure out what is the average rate of change between this point, this is f of a, and then I could also figure out I could choose the other point to be how small it moved. f of a plus h. And then we kind of see this, we can kind of see how we can find the speed or whatever between these 2 points. If I take h super small, then I can find the instantaneous rate of change. I can find the speed at that specific instant. Like maybe I might move h by 0.00001. So I'm finding the speed between a and a plus 00 or 0.0001. That's how I'm calculating on my speedometer. Instead of calculating between 2 large points like f of a and f of b, I'm actually just calculating a with a very small number after a. And that's your instantaneous rate of change. And I don't really expect much from this, but it will play a big role later on. So for now, you have all the material for average rate of change. So good luck. Take care on your homework. I'll see you guys next time.